Alright, so typically when we first introduce vector addition, one of the ways that we get you guys to understand the overall idea of what vector addition is we do it by visually representing them using size for magnitude and then obviously direction for our direction representation. So what I mean by that, our direction, again, your last video you guys viewed, okay, I looked at this north, east, south, west, okay, and again, north being 90, this being 0, this being 180. Can't see that. That's 180, and then south is 270. Okay, again, we go into much more detail under the last video, but we need those tools to be able to do visual vector addition. So the example I'm going to go over with you guys, and again, this is a nice way to teach the concept. We don't like to use vector addition visually. We like to use TRIG because there is some error in this, but anyways, we'll show you what this looks like. So my very first vector is going to be 3 meters per second. Now I'm going to let 1 centimeter on my protractor represent a meter per second, and then obviously the angle will be represented by the angle we draw these at. So I'm going to give myself a good amount of room here, and I'm going to go ahead and first just mark my starting point. So I'm going to say right here is my starting point. So I can mark my protractor and say 45 degrees right up here. Excuse me. And so then on this line that I've traced out with my protractor, okay, I need to measure 3 centimeters. Again, be careful when you do this because there's a fair amount of error in creating these. Okay, so here's my 3 meters per second at 45 degrees. Second one we're going to do is 135 or 5 meters per second at 135. So I'm going to go ahead to the very tip of the line I just drew, and we're going to complete this again at 135. Now I'm going to scoot this down so you guys can see. 135 falls right here on that G, and then I'm going to draw my line right through that. I'm going to flip this. I need 5 centimeters. So from here, 5 and back. And so those two, again, add together. We add them together, tip to tail. Tip of the last vector to the tail of the first. And again, let's label our vectors. 5 meters per second at 135 degrees. Now, to show you the resultant vector, we'll draw it in red. Again, we're using this as an estimation. Now, an example that I can give to you guys as to why we don't always use this method is because there is some measurement error, and if we went and used this method for everything in engineering with precision instruments, precision engineering, it wouldn't work, or we would have a lot more error in that. So, nonetheless, this is a good estimation and a good way to figure out kind of what we're looking at. Okay, and so looking at this vector to start out, my red vector will go, and it looks like it works its way up to about 78. This is an estimate. We can actually carry this on to get a better look at it. And so it looks like it's at about 78 degrees. Excuse me, that's on the opposite side. So it's actually going to be 90, 102. Okay, there's 100 and then 1, 2 coming along. So that's 102. And our magnitude of the vector is going to be measured out by looking at tip to tail, and it's right at 6. And again, remember, 1 centimeter is representing a meter per second. So our resultant vector is 6 meters per second at 102. Wanted you guys to be aware of how to do this. Again, adding them tip to tail. But again, caution yourself when using this because this number is an estimate. It is not perfect. If we want to be perfect, we use TRIG. Introduction to vector addition.